Okay, more exam review. Big O. Let's go for Big O. Alright, remember the rules of thumb for Big O. So, the Big O rules of thumb, let's, well, they're in the notes, so I'll just put them here and just check the notes again. So, Big O rules of thumb. You can get by, I think, with probably just a few rules here. So, exponential is larger than polynomial eventually. Polynomial larger than logarithmic eventually. Constant factors ignore. Alright, so let's see those in play here. In this notation here, these carets are exponentiation. So here we have 5 times n squared plus 2 times n to the 5th plus 2,000. I'm going to use my rules here to simplify. Constant factor doesn't matter. Just multiplying the 5 out front doesn't matter. So we're going to have n squared plus, alright, constant factor doesn't matter. This is n to the 5th. And this 2,000 is a constant. So we can just throw that out. Simplifying this more in terms of, let's make another rule here, probably a rule 0. Let's rearrange these a little bit. Larger degree polynomial is larger eventually, no matter what else is going on. And we'll put this one up front as well because that's a little, these are probably the 2 simple rules. Okay, larger degree polynomial is larger eventually. So what that means is this n squared eventually is less than n to the 5th. So then we can put it in like this in terms of Big O. Alright, and then that is 2 times n to the 5th. 2 of them. This constant 2 here does not matter, so that's really like n to the 5th in terms of Big O. Alright, similar rules. We can simplify this second one here as n to the 5 halves. The 100 times doesn't matter in terms of Big O. The plus 1,000 does not matter in terms of Big O. Alright, question for you. Now this one. First I'll tell you this 3,000 does not matter. Then we would have this here, which is n times the quantity log n to the 5th. So we have log n to the 5th power times n. Alright, can we just get rid of the log n to the 5th in terms of Big O? Answer is no, you cannot. Anything that depends on n, we can't get rid of. Here we got rid of the n squared. The n squared ends up going away because it ends up being like a constant factor, because it's really less than n to the 5th, and then we really have a constant number of these n to the 5ths, and then we can get rid of them. We still have this n to the 5th. This log n to the 5th here, it's not a constant factor, we can't just get rid of it. Okay, so that's there. That's the simplified Big O formula for that one. For this one here, this log n to the 25th, we can't get rid of that either, but we can use our rule of thumb that a polynomial is larger than a logarithmic eventually. Logarithmic means log n to some power. That's a constant. So log n to the 25th is a logarithmic function. Polynomial means n to some power, in particular n to the 1 power. So what this means is, we could say in terms of Big O, eventually this log n to the 5th is going to be smaller than n. And we would have still our n there, and this plus 1,500 doesn't matter, it's adding on a constant. Constant factors, put in parentheses to be more specific, that are multiplied or added. Alright, so these constants that are added are multiplied. this, going back up to f4 here, we have two n's, and the n, the 2 doesn't matter, so our simplified asymptotic formula would be n for this one. All right, question for you then, f5, what is the simplified big O asymptotic formula for this one? All right, here we have 2 raised to this power. That is an exponential. We have an n in the exponent. That is going to grow faster than any polynomial. That's our rule number 3. Exponential grows faster than a polynomial. So this is going to dominate the 2n, and that will end up being the most important term in our long-term running time for large n. So that's the formula. How about for f6? Note, this equal doesn't mean that they're actually equal. This is in terms of the big O formula. Maybe I could do dot, dot, dot instead. Okay, so for the last one, rule of thumb says a larger degree polynomial wins. So n to the 5th is going to be larger eventually than all the rest of these. So this is dot, 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 sort of big O less than or equal to n to the 5th times how many were there? 1. So 1, 2, 3, 4. Throw that one in if you want. That's 5. There's 5 terms. Eventually they're all less than or equal to n to the 5th. Then we can throw that constant away because we're multiplying it up front. So this is dot, 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 really big O of n to the 5th. All right, now we want to rank these. I'll label them A to something. So what's the smallest? N to the 5th, n to the 2.5, n times a logarithmic factor, just n, an exponential, or n to the 5th. So this is smallest. Second smallest. We keep going down. Let's see, this is the smallest power. We have a small power, but then some logarithmic factor. So this is big O, larger than this one. Then we go up to third smallest. And that is big O larger than this one because we could write this as n times, by our rules of exponents, that's 2.5, n to the 1.5. Okay, so we have this formula that has an n times n to the 1.5. This formula has an n times some logarithmic function. The n to the 1.5 is a polynomial. It'll grow faster than the logarithmic, so this is strictly larger in terms of big O than this one. All right, next up, we have the n to the 5ths, fourth smallest, and this one is tied for fourth smallest. In terms of big O, they both come out to be n to the 5th, even though the exact value, if you plug in the end, will be somewhat different. But their rough rate of growth is the same. And then this one is the largest. It's an exponential that's bigger than all of the polynomial stuff. Okay, so if we're writing this in shorthand notation with, let's use shorthand notation, less than is for, less or equal to is shorthand for big O. So that's my shorthand notation, meaning for big O. What else will we have? Less than for little o, greater than for, greater than equal to for big omega. Greater than for little omega, and equal for big beta. Why these Greek letters? That's life, that's what people use. They're just letters. But what they mean is this, roughly speaking. And let's put this in. So we want to say f1 versus f2. So we have n to the 5th versus n to the 5 halves. F1 is greater than F2, and it's also F1 is greater than or equal to F2. N to the 5th is, so the 5th power is greater than the 5 half power, so both of these are true. Okay, it grows faster than F2, and it grows at least as fast as F2. So in terms of these things, we have a omega and an omega. F1 is little omega of F2, and it's also big omega of F2. F2 and F3, we look at F2 is n to the 5 halves, F3 is smaller. We already just said that, so this is going to be the same. It's going to be greater than and greater than or equal to. In other words, omega and omega. Okay, F3 versus F4. We have n times the logarithmic versus n. So the n parts are the same, but then you have something that grows with n. So this will get bigger eventually. Even though log n grows small, it still grows. It grows slowly, but it still grows. So we're going to get the same result for F3 versus F4. F3 is bigger and bigger than or equal to big omega and little omega. All right, F4 versus F5. We have n versus exponential. That is very much less. Very much less. It's also less or equal to, so that's little o and big O. We have F5 versus F6, exponential versus polynomial. Exponential is very much bigger. It's bigger and bigger than or equal to, also known as omega and omega. Put these in the right order here. Omega means strictly greater than. Big omega means greater than or equal to. All right, and then the last one we have is F6 versus F1. We have n to the 5th versus n to the 5th. Those are the same in terms of big O. If they're the same, then that is equal. It's also true to say and less or equal to and greater than or equal to. So that's to say theta and less or equal to is big O, and greater or equal to is big omega. All right, so maybe you want to pause the video here to think about it. Maybe you want to pause the video here to think about it. All right, that's it for, this was some example problems, and the final will be very similar to this, where if you just remember these 4 rules, you'll be okay. Good luck, and have fun.